Students, today we study about the arithmetic progressions of 10th standard. So, from this video you have get a series of videos of the arithmetic progression of problem solving, how to solve the arithmetic progressions problems of the arithmetic progressions. So now we take an example of an arithmetic progression. So what is an arithmetic progression? If you take a series of numbers, that means here I take for example 2, that is 5, 8, 11, 14 and so on. So this is the number of series I have taken. Here you observe that one, the second number is, how can we get the second number? For getting the 5, we have to add 3 for this one. That means here 2 is the first number, we have to get the, for 5, we have to add 3 for this number. And again, for getting 8, here we have to add 3 for this one also. So that means here 5 plus 3. And this is the first term 2, and for getting the second term we have to add 3 here. And here for getting the next term we have to add 3 also. And also for getting the next term 11, we add here 8 plus 3. And so on. That means in this series of number, we have to add a fixed number for the preceding term. Here we have to get the series of numbers. We have to add the fixed number, that is 3, for the previous, that is preceding term. For 2 we have add 3, and again for 5 we have add 3, and again for 8 we have add 3. So in this way we have get a series of numbers. So this type of numbers is called the arithmetic progression. Here you observe, for comparing all the terms for the first term, here 2 is the first term, we have to add 3 for getting 5. And for 2 we have to add, that is 6 for getting the third term. That means 2 plus 6. Yes, then for getting the next term we have to add 2 plus 9 and so on. Here you observe, we have to add, for getting the next term, for the first term, the multiples of 3 here. Here we have to add the fixed number, that means for the preceding term. For the first term, we have to add the multiples of that fixed term. That means here we have to write this number as, for first term we have to write 2, and for second term we have to add the fixed number, that is 1 time we have to add the fixed number. And then in the third term we have to add 2 times of the fixed number. Here we have to add the 2 times of the fixed number. In the fourth term we have to add the 3 times of the fixed number. So that means here the fixed number is get the multiples of the number of the fixed term we have to add here. So now we have to conclude this one. That means the first term is 2, and second term we get the first term, we have to add the fixed number, that is 1 time of the fixed number, and here 2 times of the fixed number, here 3 times of the fixed number, and so on. That means for getting the last term, or we have to take any term, we have to add commonly. For 2 we have to add the any term, that means we have to add n into 3. So here for getting the nth term we have to add n into 3. Is it correct? But you have to observe here, for second term we have to add the 1 less. For the third term we have to add the 2 times of the fixed number. For fourth term we have to add the 3 times. That means the next term, first term is have 1 time, second term is have 2 times, the fourth term is have 3 times. That means 1 less than the times of that one fixed number. So here we have to add, for getting the nth term we have to add, that is n minus 1 into 3. Here we have to conclude this one as the general formula. If we take the first term as a, And here we write that for the second term, for a we have to add the fixed term is as taking as d 1 into d, and for taking this as for the third term we have to write a plus 2 into d, and for the next term we have to add a plus 3 into d. Sorry, here we have to take that is a plus 3 into d, and then at last we have to write this as a plus n minus 1 into d. That means this is the nth term of the arithmetic progression. Here for simplifying this one, we get for first term is a, and the second term is a plus 1d, and the third term is a plus 2d, and the fourth term is a plus 3d, and so on, and the last term is a plus n minus 1 into d. So this is the nth term of the arithmetic progression. Here we have to take the first term is a1, and the second term is a2, and the third term is a3, and the fourth term is a4, and so on. This is the nth term. That means we have to take on that as an. Here for the first term a1 is equal to a, here we have to take, and for a2 we write that a2 is equal to a plus only 1d. For the second term we have to take only 1d, and for the third term a3 is equal to we take a plus 2d, and also we have to take a4, that is equal to a plus 3d. That means for any term we have to take one less number of the d, we have to add the part for the first time. In this way we have to write the conclusion term, that is an is equal to a plus, that means that is 1 less than this number, that means here we have to take n minus 1 into d. So this gives you the nth term of the arithmetic progression. So this is the nth term of the arithmetic progression. In arithmetic progression we have to find out any number, any nth term or any term by using the formula, that is an is equal to a plus n minus 1 into d. So in the next video we have to discuss about how to solve the problems by taking this formula an is equal to a plus n minus 1 into d. For getting the series of the problems solving, we have to subscribe our channel and get the continued video.